Exercise 10.1 Problem 2 Division 4 Solution. Solve the equation 2x plus 1 into x minus 3 equal to 0 graphically. Okay, so as I told you earlier, we'll have to convert this into a quadratic equation or quadratic expression and equate it to y, because we have in the graph you need to have an equation or of y in terms of x, because we need x coordinate as well as y coordinate to plot the point. Okay. But before that, the product of these two equal to 0, so which means either one of them is 0. So x equal to 3 is one root, and 2x plus 1 equal to 0, or so when 2x plus 1 equal to 0, you'll get 2x equal to minus 1 or x is equal to minus half. So therefore, the two roots are minus half and 3. Keep that in mind. Okay. Right. Now let's multiply this. So 2x plus 1 into x minus 3. So that is 2x square minus 6x plus x. And 1 into minus 3 is minus 3. So this when you simplify, you'll get 2x square minus 5x minus 3 equal to 0. As I said, we'll have to have this as let y be equal to 2x square minus 5x minus 3, because in a graph you have to have x coordinates and y coordinates. Otherwise, you will not be able to plot the graph. Okay. So that's the reason we are taking it y equal to. Okay. So instead of imply, I should write let. Okay. So that is better. So let y be equal to 2x square minus 5x minus 3, and then we can plot the function of y. Okay. Right. And we know the roots are x equal to 3 and x is equal to minus half. So keep this in mind. As you can see, so the normal range is minus 3 to 3, right? We always take x is between minus 3 to 3, but in this case we cannot take that because x is equal to 3 is 1 point. So which means we'll have to extend on the right hand side. So instead of and we don't need minus 3, so we will cut short on the negative side and we'll have to extend the positive side. So the new range of x will be minus 2 to 4, because x is equal to 3 is one root. So we need to have the graph extending little more than the point, the root actually. So the next value is 4. So we are taking it up to 4. And on the negative side, minus half is enough. So minus 1 is the first point. And so we are just extending it by one more unit, that is minus 2. So instead of having a range of minus 3 to 3, in the usual case, here we are having it as minus 2 to 4, and fill up the intermediate values of x's by adding 1. So minus 2, minus 1, 0, 1, 2, 3, 4. So these are the values of x. Now we'll have to find the value of y, but y is 2x square minus 5x minus 3. So the first row is x square and the second row is 2 times 2x square, because that covers this one. Then this the third one, the next one will be minus 5x, and the next one will be the constant minus 3, right? So minus 3, you fill it up in all the places actually in this row. So you will, because it's a constant. Now you see x is minus 2, so x square is 4. So minus 1 square is 1, 0 square is 0, 1 square is 1, so on. You can fill it up. 2x square is 2 times this value, that is 4 2s are 8, 1 2s are 2, 0 into 2 is 0, 1 into 2 is 2, and so on. Minus 5x is minus 5 into this x value. So minus 5 into minus 2 is 10, minus 5 into minus 1 is 5, minus 5 into 0 is 0, minus 5 into 1 is minus 5, and you can fill the remaining values. And minus 3 is a constant which needs to be added, so all the cells are filled with minus 3. Now to get the value of y, we need to add only these 3 cells, because here the expression of y is 2x square minus 5x minus 3. So if you add these 3 cells, we'll get the value of y. So 8 plus 10, 18, 18 minus 3 is 15. So when x equal to minus 2, y equal to 15. Then in this case, 5 plus 2 is 7, 7 minus 3 is 4. Like that, you can fill up all these cells in this row. Right. Now you see the range of x. X is varying from minus 2 to 4. So 4 minus of minus 2, that is the highest value, minus of the smallest value. 4 minus 2, because the lowest value is minus 2. So it becomes 4 plus 2 is 6. 6 is okay, so we can keep the scale as 1 centimeter equal to 1 unit. But now take the case of y. Y is the highest value is 15 and the smallest value is minus 6. So highest value minus smallest value is 15 minus 6. So 15 plus 6, that is 21. So we have to have the scale as 1 centimeter equal to 2 units for y-axis. And you see y is there and negative y is there as well as positive y is there, right? And the same goes for, it is more on the positive side than on the negative side. So we will plot it equally both sides. Okay, so now we have the scale. Next we'll have to collect all the points. So it is minus 2, 15 is 1 point, minus 1, 4 is another point, 0 and 3, minus 3, that is x value and y value together as a pair is our point, right? So 1 minus 6 is another point and goes on. So I'm getting all the points here. So what is next? We'll have to draw the x-axis and y-axis and write the units on it as per the scale. So we have the x-axis and the y-axis. As we said, 1 centimeter is 1 unit on the x-axis. So it is 0, 1, 2, 3, 4 on the x-axis positive side, and the negative side minus 1, 2, 3, 4 up to minus 8. I've taken it from minus 8 to 8 to make the the screen is wider. So I have to have it, otherwise it becomes the graph becomes too small, sorry, too wide. So that's why I'm adjusting it as per your sheet size. You can have it minus 6 to 6 or minus 5 to 5, whichever suits you. Okay, as far as x-axis is concerned. And on the y-axis, we know the highest value is 15, right? So we should at least have 16 on both positive and negative. So that is why I'm having it up to 16 here, right? So what are we doing? So what is happening? So from here, the y-axis 1 centimeter equals to 2 units. So 0, 2, 4, 6, 8 up to 16, because we have the biggest number on the y is 15, right? Yeah, here we have. So we are having it up to 16. And the negative value, negative y, I'm taking it to the same. But if you want, you can cut short on it. The smallest value is minus 6. So maybe at minus 8 you can stop it. But I have just for symmetry, I've done it so. So 0, minus 2, minus 4, minus 6, minus 8, minus 10 up to minus 16. Okay, if you want, you can cut short on it at minus 8. It's up to you. Next, we'll have to plot the points. This first point is minus 2, 15. X is equal to minus 2, y is equal to 15. X is equal to minus 2. This is the one. And y is equal to 15. This is 14, this is 16. The midpoint, this is this marker. On your graph sheet, it will be very clear, right? So this is 15. So on the horizontal line along this 15, and vertically up it meets, and this is the point. Okay, next is x equal to minus 1, 4. X is equal to minus 1, so this is the one, and y equal to 4, 2, 4. Okay, so this is the one. So horizontally coming down, up, come horizontal, and then go up, so meets at this point. So minus 1, 4 is another point. Now let's take this one. X is equal to 2, y is equal to minus 5. X is equal to 2, y is equal to minus 5, right? So horizontally coming and vertically down, it meets. So this is 2 minus 5. Like that, you can plot all the other points, and you can see the plots fall on the x-axis. So these are the roots. That is when this is one root, and the other one is actually x is equal to minus half. Okay, the other one you will be able to find it when you draw the curve. Actually, you can see it here. It cuts somewhere here. So x is equal to minus half will be the other place where the curve cuts the x-axis, right? Now everything is done. What will we do? We'll join all these points using a scale with a very thin and a light line. Okay, it should be just visible to you only. Once that is done, using that line as a guide, connect all these points freehand and form a smooth curve. Okay, I have done that here. So this is a smooth curve, and write the equation, the function here, right? So now the graph is more or less done. We just need to interpret it. So we are asked to find the roots. What are the roots? When y equal to 0, or when the graph cuts the x-axis. So this is one root, and where is the other place? It cuts here. So where it cuts at that marker, that is at when the midpoint. So this is 0, this is minus 1, so this is minus half. So the roots of this equation are x equal to 3 or x equal to minus half. Right? Now let's take a quick look at the graph. We have labeled the axis, we have put the values, we have drawn the curve, made the plotted the points, drawn the graph, drawn the curve if not, and we have written the function and we have written the scale. So everything is done. So it looks like fine. It looks fine. So let's go ahead and write the roots. So the curve intersects at minus half, 0, or the intersecting point is minus half, 0 and 3, 0. And what is our solution? Roots are nothing but the x values of the points where it cuts the x-axis. So x is equal to 0.5 minus 0.5 or x equal to 3 are the two roots, and that is the solution set. Okay. So I hope it's clear. If not, please go through one more time. It will become clear. Thanks for watching this video.